Howdy, boys and girls. Today we're doing solving equations day 2. So why don't we go ahead and jump straight into it. Example 1 is 2 sine squared of x minus 5 sine of x minus 3 is equal to 0. Now, there isn't many equations on our formula chart that are going to let us deal with this type of form. But if I realize that it kind of looks like 2x squared minus 5x minus 3 is equal to 0, well, then this kind of reminds me of back in my algebra days, where we needed to factor this in order to solve it. So that's what we're going to do. We're going to factor it. And this is going to factor into 2x times or plus or minus something times x, because this is x squared. 2x times x is x squared. And the factors of 3 are 3 and 1. But I need a negative 5, so that's going to be like minus 6 and a plus 1. So that's going to be a minus sign, and it'll be a plus. And I set these equal to 0, and there we go. But being my problem wasn't given in terms of, or I was given signs and not x's, I need to rewrite this. So this will be 2 sine of x plus 1 times sine of x minus 3 is equal to 0. Now, if you don't believe me, you can go ahead and pause the video now and distribute these back to make sure that we get this equation right here. But why don't we go ahead and continue. Now, this entire left-hand side is equal to 0 when either 2 sine x plus 1 is equal to 0 or sine of x minus 3 is equal to 0. So what I'm going to do is I'm going to set both of them equal to 0, and I'm going to split it up into two separate problems. So right here I'm going to write 2 sine of x plus 1 is equal to 0. And over here we'll write sine of x minus 3 is equal to 0. So why don't we go ahead and solve this guy first. So I'm going to solve for sine of x on one side and everything else on the other side. So it's going to be a subtract 1 and divide by 2. Okay, now I need to know the sine of what angle is going to give me a negative 1/2. So I'm going to go ahead and draw my triangle. Sine is negative in the third and in the fourth quadrants. Sine is opposite over hypotenuse, opposite over hypotenuse. And that would be a root 3 because I know my special right triangles. And that makes this right here a 30-degree reference angle. So I'm given two triangles, each with a 30-degree reference angle, and I'm going to actually redraw. Actually, no, I won't redraw those. But in order to give a general solution for this problem, so I'm going to do my general solution in red, is the gen solution, SOLN, my abbreviation for solution. I need to figure out what this reference angle is. So that'd be 180 plus 30, which is 210. Now, 210, and I need all coterminal angles with 210. So in order to get a coterminal angle with sine, I need 210 plus 360 n. That's one general solution. My next one, which I'll do in green, I need to go from the positive x-axis all the way around over here to the second angle, this guy right here. And I know that this is 360, but 360 minus 30 is 330. So this guy will be 330 plus 360 n. And these are my two general solutions. So this is x equals and x equals. I'll box those in blue. So this is two of my solutions. Now let's see if this other equation gives me anything. Now, to solve sine of, where's my cursor? Oh, there it is. Solve sine of x minus 3 is equal to 0. I'm going to add 3 to both sides. So I get sine of x is equal to 3. And then what I'll do is I'll take the arc sine of both sides. So the sine to the negative 1 of the sine of x is equal to the sine, oh, I gotta move over, the -1 of 3. Now I know that the sine of the arc sine cancels with the sine, and I'm left with x equals the arc sine of -3. But as we remember from doing arc sines, 3 is not in the domain of arc sine, so this is no solution. So this guy contributes nothing to the solutions, to our general solutions. So what we have boxed is our only answer. Okay, so why don't we go ahead and move on. For number 2, we have the sine of 2x cosine x plus cosine of 2x plus the sine of x is equal to 1. Now I'm going to pause the video and I want you guys to go and grab your formula charts. And I want you to look at your formula charts, namely, actually, I don't remember what side because I don't think I told you what a front and the back was. So I want you to go look at your formula charts and I want you to look for something that looks like this. Except you're probably going to have A's and B's. And when I come back, I'll have it written down. So I'll see you guys soon. Well, welcome back, guys. I hope you guys got some snacks, or at least your formula charts, and that we see that the sine of A plus B looks a whole lot like what we have. Now, our A is going to be 2x, and our B will be 1x. So this guy right up here is going to be equal to the sine of 2x plus x, which is also equal to just the sine of 3x, which is equal to 1. Well, the sine of 3x is equal to 1, we can solve. We know how to solve this. And what I'm going to do is I need to figure out the sine of what angle is equal to 1, or another way to rewrite that question is this 3x is equal to the arc sine, or sine to the -1 of 1. And in order to solve an arc sine of 1, I'm going to draw, there we go. I'm going to draw my unit circle. Now, guys, I'm going to pause and fix that real fast. Okay, well, I'm back and I fixed it. Okay, so to reiterate real fast, I'm finding 3x is equal to the arc sine of 1, and in order to do the arc sine of 1, I need to draw my unit circle. And I realize that sine is the y value, and this is 0, 1, which is also cosine sine. So the sine of 1 is right up here at pi over 2 degrees. I'm going to do this or pi over 2 radians. I'm going to do this in radians. So 3x is equal to pi over 2. Now, how do I get all the way around the triangle in radians? Well, I add 2 pi n. So plus 2 pi n. Well, I am almost there, guys. All I need to do is get x by itself, so I divide both sides by 3. And I get that x is equal to pi over 6 plus 2/3 pi n. And this is my general solution. I'll box it in red. So this is all I needed for a general solution. And sometimes I don't want a general solution. Well, I want general solution. A lot of you guys ask, well, Mr. M, when do we need general solutions? Guys, I want general solutions when you see x is in the set of all real numbers. So if you see this, this means general solution. But if you see that x belongs to the set of, let's say, 0 to 2 pi, and I want x such that it's in between all x values that are a solution that are in between 0 and 2 pi. So why don't we go ahead and find the solutions that are in between 0 and 2 pi, and I'll do this in purple. And in order to do this, I'm going to plug in different whole integers for n. So n is just numbers like -1, 0, and 1, and they go on in the infinities in both directions. So why don't we go ahead and plug in 0. If I plug in 0, I just get pi over 6 plus 2/3 times pi times 0, which is just 0, so it's just pi over 6. If I plug in 1, well, that's going to be pi over 6 plus 2/3 pi, or 2 pi thirds. And another way of writing 2 pi thirds is is 4 over 6. So plus 4 pi over 6. So I'm just adding 4 pi over 6 each time. So that would be 5 pi over 6. And then we're going to plug in 2 for n, and it'll be pi over 6 plus 2 over 3 pi times 2, or 9 pi over 6. And guys, don't be afraid to go ahead and pause this video if you don't believe me. And then if we plug in 3, we'll get 13 pi over 6. But 13 pi over 6 is bigger than 2 pi. It's actually 2 pi plus pi over 6. So I don't need it. So my only specific solutions are these guys. And those are from in between 0 and 2 pi. Okay, why don't we go ahead and skip down to this last one? Now this last one looks a whole lot like some of the problems we were solving yesterday in class, or today in class, depending on when you watch this video. Okay, so we have 4 sine squared of theta plus 50 is equal to 3. Well, first I want to get rid of this 4, so I'm going to divide everything by 4. I have the sine squared of theta plus 50 is equal to 3 over 4. My next step is going to be to take the square root of both sides. When I take the square root of something, I have to introduce a plus minus. So I get sine of theta plus 50 is equal to plus or minus the square root of 3 over 4. And this is also equal to plus or minus the square root of 3 over 2. So I'm going to go ahead and copy down the sine theta plus 50. Now, this plus or minus just means we break this problem up into 2 different sections. So we will have, I'll do one over here. Namely, I will do the sine of theta plus 50 is equal to positive root 3 over 2. And over here, I will do the sine of theta plus 50 is equal to negative root 3 over 2. And actually, I'll do that half in blue. So we'll underline it in blue. This guy will be in, green. We'll do that in green. Because green, right? I hope that's green. Okay, so in order to solve, so we'll do this one first. So in order to do this, we're going to take the arc sine, or I need to know the sine of what degree measure will give me a root 3 over 2. So we don't need to write the arc sine. I can just go ahead and draw my triangle. And I know that root sine is positive in the first and second quadrants because all students take calculus. So let's go ahead and complete it. All students take calculus, so it's positive here and here. And sine is opposite, so it's the square root of 3 over, with a hypotenuse of 2, root 3, 2, makes this a 60 degree, and this 60 degree reference angle. So my first angle is going to be 60 degrees. My second angle will be 180 minus 60, or 120. I'll write those down here in a minute. So we have the theta plus 50 is equal to 60 plus 360n. And remember, we do the 360n to get all coterminal angles with this guy. And I said I was going to do this in green. So we're going to continue in green. Multicolor notes. Woohoo. Okay, so now I just need to solve for theta. So theta is equal to, subtract 50 from both sides, is equal to 10 plus 360n. And this is my first solution, my first general solution. Okay, my next one is going to be this guy, which earlier we said was 210 because that was 180 minus 60, which is 120. I'm sorry, I misspoke. So theta plus 50 is equal to 120 plus 360n, and we subtract over 50, and I get theta is equal to, let me look at my notes, 70. Yep, theta is equal to 70 plus 360n. And this is my second general solution. Okay, now let's go over here. So that gave me my two general solutions for this half of the problem. Now we jump over to my second half, and we're going to do the same thing. I'm going to write it a little bit differently. I'm going to take the arc sine of both sides, and this is just to show you the fact that we can do it either way. So we have the arc sine of the sine of theta plus 50 is equal to the arc sine of negative root 3 over 2. So these arc sines cancel, and I'm left with theta is plus 50 is equal to the arc sine of negative root 3 over 2. Okay, and once again, I'm going to draw my coordinate systems, and I know sine has a negative root 3, sine is equal to negative root 3 over 2 in the fourth and the third quadrant, and it's negative root 3, positive 2, negative root 3, positive 2, 1, negative 1, and once again, that's still a 60-degree reference angle. And this first one is going to, we measure from the positive x-axis, so starting right here, and we go straight to this line. So it's going to be 180 plus 60, and 180 plus 60 is equal to 210. No, 180 plus 60. So we have theta plus 50 is equal to 240. So this is 240 degrees. This is 240 degrees. Is that measure right there, plus 360n. And once again, that 360n for the third or fourth time, so that we get a coterminal angle. So now I'm going to solve for theta, and theta is equal to, well, 240 minus 50 is 190. So it's 190 plus 360n. And that's my third general solution. And last, we're going to deal with, I'll do this in black now. We need to go from all the way around here to right here, which is the same as, well, 360 minus 60, because that's a 60-degree reference angle right there. So theta is theta plus 50. Oh, where's my marker? Oh, sorry guys. Theta plus 50 is equal to 300 plus 360n. I'm going to subtract 50 from both sides. I get theta is equal to 250 plus 360n. That is my last general solution. Now, being I have general solutions, it would be just as easy for me to find specific solutions given a certain boundary or a certain set or a certain interval that I'm looking forward. So it's like if I wanted to do x is in between 0 and 360, I would just need to plug in values of n into each of these equations and write what they would return. So for this first equation right here, if I plugged in 0, I would get 10. So I'm going to write 10. If I plugged in 1, I would get 370. 370 is bigger than 360, so I'm not going to write it. Now I go to this next one. If I plug in 0, it returns 70. I plug in 2. If I plug in 1, it returns something bigger than 360, so I'm not going to write it. Now I go over here, same song and dance. I can plug in 0, but not 1. It returns 190. And right down here, if I plug in 0, I get 250. So these are the 4 degrees, or 4 values of x that make this statement up here true. Okay, guys, well, I will see you in class tomorrow. Have a great evening.